Okay, got a vector function here that defines a region in the xy plane. Vector function's cosine cubed t times I plus sine cubed t times j, where t goes from 0 to 2 pi. Now you notice if it was cosine squared plus sine squared, that would give us a very standard parameterization of the unit circle with an area, enclosing an area of pi. Okay? Cosine cubed and sine cubed are almost always less than the cosine or the sine. That's because, of course, the cosine and the sine are almost always less than 1. So when you cube a number less than 1, you're multiplying its square by a number less than 1, which gives you something smaller than the square. Okay, well, there it is. We can easily minimize some functions and so forth using calculus and verify that the minimum possible value of the square of this plus the square of this occurs when t is, or when t is thought of as an angle that's at 45 degrees to either of the axes. So we can easily get this shape, but we can easily just plug in some numbers and see how it works. Better to use calculus to understand the shape. Now that's not necessary to solve the problem, but this is what the region looks like, and we can then estimate the region. We can estimate the area of the region to be, just looking at it, if the area of this region, the circle is a little over 3, which it is, then we say that we probably have about 2/3, 3/4 of the area. Maybe it's 2.4. Okay, well that's just a ballpark estimate. What we want to do is integrate to find the area, and we could easily do that by doing, partitioning the x-axis, just say for one quadrant, from 0 to 1, and the y value and so forth, and do what we need to do with these coordinates to get this in terms of this. It'd be a little messy, but it's feasible. The integral would be probably fairly ugly. Or we can use Green's theorem. Okay, Green's theorem tells us, of course, that for any region D, and we're going to think of this region, the shaded region, as being the region D, the integral of qx minus py with respect to area is the integral over the boundary of p dx plus q dy. Okay, well, if we want this to be the area of the region, then qx minus py needs to be 1. So we want to find a q and a p such that qx minus py equals 1. Well, it's easy to do that. We could let q equal x and p equal 0. Then qx is 1, py is 0, so we have 1 here. Or if q is 0 and p is negative y, then py is negative 1, so negative py is 1, and qx is still 0. Parameterization your text uses a lot, and one that's not a bad idea is q equal x over 2, p equal negative y over 2. Clearly then qx minus py is 1/2 plus 1/2, which is 1. To apply Green's theorem, we then integrate. We get the area integral by integrating along the boundary. So our integral of p dx plus q dy using this parameterization, well, x is cosine cubed of t, y is sine cubed of t, so that dx is, well, derivative of the cosine cubed, or the differential of cosine cubed. I left off my dt here. Okay, dx is negative 3 cosine squared t sine t, dy 3 sine squared t cosine t, both times dt. So that our integral of p dx is going to be that was bothering me, is going to be x over 2, which would be cosine cubed t over 2 p dx is x over 2 dx. X is cosine cubed t, so it's cosine cubed t over 2 times our dx, which is going to give us a cosine to the fifth here. And of course, it's going to give us a half. And there's a 3 in there, so that should actually be a 3/2. I shouldn't even have anything in front of that. P dx plus Q dy. Okay, and that gives us the 3/2 over here. Okay, so we got 3/2 here, and then P is x over 2 again, cosine cubed times dx is going to give us cosine to the fifth times the sine. And when we do the y over 2 dy, we're going to get y being the sine cube, we're going to get a sine to the fifth t cosine t dt with the 3/2 that comes out from just doing the arithmetic. So we put it all together, we get this, and we get 3/2 integral cosine to the 6t plus sine to 6t evaluated between 0 and 2 pi, which gives us 0. Well, that could mystify us a little bit, and because clearly the area of this thing isn't 0. So the question is, we obviously did something wrong, and what is it that we did wrong? And the one thing that we didn't get right here is that cosine to the fifth t sine t plus sine to the fifth t cosine t is an odd function, and we should have been, in a sense, integrating the absolute value of that function. If we integrate this over just 1/4, over just one quadrant. Okay, so integrate in one quadrant, then the integral would go to pi over 2. We'd have this, but of course there are 4 quadrants. Still bothers me that we're going to go on with it. If we have 4 quadrants, then we see that we have now what I'm going to get isn't all that great either. Cosine to the 6t from 0 to pi over 2 is going to give us 1. This is going to give us 1. That adds up to 2. 3/2 of that doesn't make me all that happy either. That's going to give us an area a lot bigger than pi, so gee, I thought that was going to fix it, but it didn't. So I still don't know what's going on here.